listeners, Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India, through its National Council for Science and Technology Communication and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Charvi and post-production by Professor Kaushik P. Kanchan, Krishna Kapil, Malla Tejesh of Garden City University, Bengaluru.
Garden City University, conquer we shall all adversity. GCU, emphasis on life. GCU, emphasis on life.
This is Charvi, your narrator for the podcast. Today, we are joined by Dr. Viswanathan, a renowned physicist with a stellar career spanning prestigious institutions worldwide. Dr. Viswanath completed his PhD in Physical Sciences from the Raman Research Institute in Bengaluru in 2004.
I am Dr. Viswanath. I work at the Center for Nano and Soft Matter Sciences as a scientist. I have a small research group. It's about 3. And 5 people have passed out after doing their PhD. We work in the area of phase transition in thin films and patterning metal surface for plasmonics and optical wettability application. So what I could see in the short term is like after patterning these surfaces, we can utilize it for harvesting the fog. So when we harvest fog, we get water. So this get water from air, from a thick fog conditions using surface treatment. So we play with different regions of the surface which has different affinity to water, and it can nucleate and grow the water droplets as the fog is impinged on that. So this is one part which we are trying to address it at present. And the second effort is towards understand the polymeric skin formation. When you keep some polymeric solution, expose it to air, you have a thin film formation of the polymer, and this film skin has a different properties than the bulk solution, and this is a nuisance in the industry where they would like to avoid this skin layer formation because of the polymer. So you have 2 separate layers. One is elastic skin at the surface and another one the solution in the bulk. So we would like to understand more about this formation of the skin, because this is also pervasive in the painting industry, wherever and milk, for example, that also has a skin layer as we boil it. So this is what we would like to address. In India, we are a tropical country. We have a shortage of water with many people, scarcity because of there is also more of exploitation of underwater resources, and we are not recharging it properly. But what is abundant is in the atmosphere we have a lot of water vapor, and this water vapor is being trapped. So using these surfaces which are patterned, you can harness and trap the water through fog conditions. So this is what we are trying to do in the lab. So this is one effort which we are trying to do in a small scale too, but and it might have an implications in the water harnessing, harvesting of water. This is like a sheet. Basically, see, we all have this. What we have attempted is we have a silicon solar panel. This silicon solar panel post its end of life. It's as a waste product. We can pattern this substrate of the silicon with the metallic parts, and we can functionalize that. Suppose one part likes water, another part hates water. When we send a stream of fog onto that fog can be trapped as a droplet, and this droplet can be channelized and moved in a particular direction. That leads to you can harness and transport the water, and we can harvest it also. So this is one aspect. So this needs patterning of surfaces, which we are trying to use in a nano and micro scale regime. This is at present in a research scale we are doing, not on a large scale. But we can pattern this. If you are successful in patterning it over a large area, then it can be very effective to transfer. At present, it is in maybe about centimeter scale in a lab project. But to extend it further, we may need better techniques to facilitate patterning over a large area. Those are not potable water, that is grey water they call, which is once used and then that can be used for gardening purposes. But there are some labs wherein they have tried to use salt. Salt is effective towards absorbing water moisture. So that salt it can trap this water, and they have a means to also release the water. So they use this for making some brewery condition. There is some in Bangalore. We have some other company by name Muravu who is into this aspect of looking at trapping water. So, and also thermal desalination, that's also another effort which has been going on. So these are some efforts which is towards the societal impact which can be of also helpful to society when you try to trap water, because water is a major source for living and also used in industry in many scale and agriculture too. So at present it is not in a mature state, but not this technique especially, whatever I have discussed in which we are attempting in the lab. But there are other techniques like using mesh, cloth-like mesh in a hill station. And hill station is mostly deprived of water because of rocky regions there. There is no aquifer there. So what people used to do is put a mesh there and then collect the water over there. But what we expect from our technique is to have the efficiency to be more compared to what we get it through the mesh, which is not very specific to the vapor. Here we have a potential trapping site for the vapor, which leads to condensation of this water. So that is what we are trying to attempt. This is from the part of our research, one of the major effort which is going on.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and through Spotify, YouTube and Apple Music platforms.
आइए हम सुने विज्ञान की अनसुनी कहानियाँ, एक नई दुनिया की